Hello, everyone. Welcome to this session of the DBA Fundamentals Virtual Group. We have an awesome speaker tonight. Today, it's midday for us. It could be anywhere for you guys. Someone's already said good morning in the questions. So we have from SQL Skills, we have Jonathan Kehayias, and he's going to be speaking about deadlocking for mere mortals. And he's already let us know he can speak forever about this topic. So we're going to limit it to an hour. Definitely make sure you guys ask questions along the way. He'll be watching for those. And whatever we can't get answered during time, we can always make sure we get those questions to him to be answered later. A little bit of housekeeping before we get started. This title slide has a lot about our virtual group. So the organizers' information is in the top right. There's Steve, Shane, Warwick, Kevin, and I. We're all organizers and try to get your questions answered and try to bring up this great speakers and great content for you guys. You can look at us online at dbafund.org, and it takes you to the past site for our specific group, and you'll be able to see, get this off on the screen, you'll be able to see the list of all the sessions that are upcoming and see some of the past things and all that kind of stuff. We also have all of our sessions recorded and uploaded to the past YouTube channel. There's also a way to get to them through the Learning Library, which seems a little bit easier sometimes. So past.org and go to the Learning Library. You can also message us at DBAFun. All of us check that, so you can you'll get one of us for sure at DBAFun on Twitter. And then the Slack community is awesome. So if you haven't been on that already, sequelps.io/Slack and sign up for the SQL community. One of the channels is the DBA Fundamentals. There are so many channels, and it's a great way of interacting with the SQL community and not being limited to, actually, I don't think it's limited to 120 characters on Twitter anymore. So, but still, it's both Twitter and Slack, awesome in the community. And then you can check us out on LinkedIn as well. We have the DBA Fundamentals group there, and we have, I know he posts up some articles sometimes and some discussions. We wouldn't be here today without sponsors, so we're going to go over both sponsors here. One of them is SentryOne. They have a ton of information out on their website, SQLperformance.com, and they have blogs, and they have one big page full of nothing but links to other resources. So rather than listing them all here, they have centuryone.com/resources, and it is nothing but just a page full of links that have awesome content. They also offer free query tuning advice. You can also download a free trial of their software. And their Plan Explorer is free. It's a plugin for Management Studio, and it's a great way of seeing the execution plans in a little bit more visual way than just the default. I love it. It's amazing. So check it out. Our second sponsor is DBA Watch, and they really have a complete solution for quite a bit. Administration, monitoring, performance, security, and license management. And it works for other platforms, SQL Server, Oracle, and others. They also have quite a bit of stuff in their blog. It's blog.dbwatch.com. And they also offer the free trials for their software as well. We are a member of PASS. We are part of their groups. And there are several virtual groups out there. Anything you can think of, there's going to be some kind of virtual group out there. And they all do sessions just like us. So anything you're looking for, want to learn more in, things like that, check them out and find out the sessions they've been doing or have upcoming as well. Another great thing about that PASS actually offers are SQL Saturdays. And what's really awesome is I actually have been able to meet Jonathan, our speaker, in person. So at a SQL Saturday, they're a free event, and it's just a great way of networking and getting some free learning. These are the upcoming all across the world. Actually, Tampa's coming up. That's interesting. I need to go. But also Baton Rouge in Louisiana, Chicago, Cincinnati, Boston. So there's quite a few coming up. check out SQLSaturday.com to find out all of them throughout the remainder of the year. And with that, I'm going to turn it over to John. Let me make you presenter. All right.
So let's see, show screen 2. Can everybody see my screen?
Yes, we see your slideshow.
All right. So I'm going to go ahead and start. My name is Jonathan Kehayias. I'm a principal consultant with SQL Skills. Probably the most important thing, I guess, on what I always call my Yay Me slide would be the way to contact me. Jonathan at SQLskills.com is my email address. I'm on Twitter as SQL Poolboy. And I do blog at SQLskills.com as well. I always say if you ever have a question about something that I presented, feel free to shoot me an email. We respond to a lot of emails all the time. If I'm out of the office, you'll simply get a response that says I'm out of the office and when I'll be back. But otherwise, let's move on with the session. So I do work with SQL Skills, Paul and Kimberly, Tim and Aaron. We do a lot of instructor-led courses online. Glenn used to work for us. I need to update my slide through last year. And we're also recording a bunch of content for Pluralsight. And then we just offer the standard consulting services, health checks, hardware recommendations, performance tuning, upgrades. And I do speak at a number of conferences, including Past Summit last year and SQL Intersection. So what we're going to talk about in this session is an overview of deadlock analysis. So we'll start off with a review of locking in SQL Server. We'll talk about what a deadlock is, and then how do we go about collecting deadlock graphs? How do we read those? And then what do we do to resolve deadlocks potentially as it relates to SQL Server? Now, there's a lot of misconceptions that exist about deadlocks. Probably one of the biggest ones being that they're a bug in SQL Server. In most cases, that's not really true. Usually, they're just a condition as a part of either application code or schema design that allows for a cross-locking scenario that generally results in one of the sessions involved being killed by the engine. Another one being deadlocks cannot be prevented. And I have said this, I think the first time I presented this session was for SQL Rally, which was supposed to be a complement to Past Summit back in the 2008 timeframe. So almost 12 years I've been presenting this, and I've said it every single time, and I haven't been proven wrong yet. Deadlocks can be prevented. I've never found one I can't offer some kind of a resolution to, but I do run into a lot of DBAs and developers that don't want to make the changes required to prevent the deadlock from occurring. And we'll talk about what can you do if you have one of those situations that the necessary change, maybe to the schema, indexing strategy, or code can't be implemented. What can we do so that it's not a user problem still? Probably one of my least favorite suggestions that used to be pervasive on the forums is to use no lock on all select statements. It used to be very common that anytime somebody asked a question about deadlock, one of the first responses was just use no lock, just use no lock, just use no lock. And I hate that advice for a lot of reasons. Not because it can't prevent certain types of deadlocks, it absolutely can, but because you don't know anything about that workload and whether or not no lock is an appropriate recommendation, because you're trading off lock concurrency for the potential for dirty reads. Do I want somebody to get a no locked result set back from my bank? Probably not, especially if I have transactions in flight that would be modifying my available balance. I don't want somebody checking my balance or getting an incorrect result there. So it's not to say that that isn't potentially a solution for certain scenarios. It's just not the ideal one that I would ever recommend off the go. Um, the other interesting thing about that is I used to have a couple of examples that I would bring up when I was teaching. The recommendation to use no lock when it's a update deadlock or a modification against modification deadlock scenario. That doesn't ever work because modifications inside of SQL Server require locks unless you're on a later release of SQL Server and using in-memory OLTP. Then everything that I'm talking about doesn't apply related to that scenario because that's a different implementation of row management inside of the engine entirely. It's designed to prevent lock collision issues and scenarios and blocking. Another misconception, adding covering indexes or changing indexes for every type of query will prevent deadlocks. There are certain cases where this can happen, but it can lead to an over-indexing of the tables inside of a database if somebody's doing this. Most of the time where I see this happening, the non-clustered indexes on a table are all prefixed with underscore DTA underscore index underscore. And what happened typically is somebody runs into a deadlock, they grab a statement, they run it through the database tuning advisor, it makes a recommendation, they apply the recommendation. Probably the worst case that I've seen for this was a table with 14 columns and 42 non-clustered indexes on it. There's a lot of duplication, a lot of overlap. And anytime somebody changes a query that used to be covered and they add a single column, it becomes non-covering again, and we can end up with the same deadlock scenario. So there are cases where making index changes are absolutely the best solution, but sometimes we might need to look beyond that and beyond what we're seeing for just this one condition and what's the overall workload. And the last one, troubleshooting deadlocks is a complex task. It actually isn't that complex if you have looked at the deadlock graph and you understand what it's presenting to you, which is the point of this session. I started troubleshooting deadlocks back in SQL 2000, and back then it actually was a very complex task. SQL 2005 really changed that with the information that's presented in the deadlock graph. And usually everything you need to know is in one output. So you don't have to go digging through traces and merging information from trace flags from the error log to figure out what's happening. If you're on SQL 2000, I'll take back what I said earlier. Don't send me that deadlock because that's a very difficult thing to troubleshoot. And you need both the output of SQL trace along with trace flag outputs from the error log. And my recommendation to you would probably be it's time to upgrade and move off of that. Every now and then we run into people that still have it. We know it's still out there, but that would be the scenario where I would tell you I can't troubleshoot this by email. So somebody asked, how do you say a table has too many indexes? Is there a number to is there a number to limit number of indexes on a table? So how do you say a table has too many indexes? That's a really difficult question to answer in an hour time block. It depends on the workload. I am not an indexing expert by far. There are cases where you might have indexes that overlap or left base subset duplicates of each other for performance reasons, simply because the page count is smaller when you have a really wide schema on the table. And the engine can drive on those. It really is a matter of workload, filter criteria for your queries, size of the data set potentially. There's no one size fits all answer there. and it really is. I think Kimberly or Aaron could probably talk for days on indexes, and I fall asleep when they start blah 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 blah. Um, it I understand indexing to the point that I know how to use them for performance tuning, but um, there is no like one number fits every scenario. Usually, if I'm looking at a table, um, uh, and there's more than 10 non-clustered indexes, depending on the schema, how many columns are in the table and how is it queried. I start looking at it a little closer. The real key there would be looking at your usage stats and checking the information that's there overall. Now, some terminology. The key to understanding deadlocks in SQL Server is to understand what uh, you're looking at in the graph. So when I talk about a transaction as a part of a deadlock, I'm talking about just a unit of work done inside of the database. Locks are going to be our synchronization mechanism on a resource, and a lock is there to protect it from being changed by multiple concurrent transactions at the same time. Every lock has a lock mode. That mode is what defines the level of access another transaction can have while the resource is locked. Blocking is what happens when a transaction requests a lock mode on a resource that has a conflict with a currently held lock on the same resource. So we're trying to read a page with a shared lock and somebody's modifying that page with an exclusive lock. At the page level, those are conflicting. The shared lock is going to be blocked until that exclusive lock gets released. And then a deadlock is a condition where two transactions end up blocking each other in a circular fashion. So one is acquired locks on one resource, the other's acquired locks on the other resource, and they're attempting to acquire locks on the opposite resource in a conflicting mode. Narav says, I have seen in my production environment most of the time the deadlock due to indexes or same update statement run multiple times. We'll talk about some of those conditions. Uziel said a select statement running can be considered a transaction. Yes. A select statement absolutely can be considered a transaction because the locks associated with that select statement are held for the duration of the operation. So it is a unit of work. Is it a explicit transaction like you would get with a begin transaction block? No. Is it logging information with no change? No. So there is a difference between what we would call an explicit or implied transaction for data modification that actually logs information to the error log, or I'm sorry, the transaction log, and what would be a unit of work, which is the transaction scope for a select statement. So our locks inside of SQL Server start at the row level as the lowest level of granularity. And there we have two different types of locks. There's a RID lock, which is the row identifier for a single row in a heap. And then there's a key lock, which is a single row and an index, whether it's clustered or non-clustered. So when we're dealing with heaps as a part of the schema, you're going to see row identifier locks. And that row identifier is a 4-byte uniqueifier that's tagged to the record so that the engine can uniquely identify it. Then we have page level locks above that where a single page in the database is locked. We have Hobbit, heap or B tree, partition level locks. We have table, object level locks, and then we have metadata locks. And there's a few other lock types in between. For example, there's extent-based locks. But typically when we're dealing with deadlocks, we're going to see locking at one of these levels in conflict with each other. Now, as we work down this list, the amount of concurrent access transactions have to the data decreases. So if we're locking at the page level, everything on that page is considered to be locked. So if there's 1,000 rows and we have a shared lock, nobody can modify one of those rows because they're going to require an exclusive lock to make the modification. If we escalate to a full table lock due to lock escalation, we have the only lock that's compatible with that operation. If we are reading data and we get a shared lock, other readers can get in, but writers won't be able to. If there's a writer that's blocked, everything else begins to block behind it. And it does that inside of the engine to prevent a thread from having to wait infinitely. So once we have one blocker, one block session, everything else that's attempting to acquire a lock is going to be blocked by that session if it's in a conflicting mode to its lock. So some things to keep in mind there. And then our schema locks are strictly for our DDL statements where we'll get a schema mod lock. Otherwise, everything else is just a schema stability lock. Now, the higher up this list we are, the higher the number of locks. So if we go back to our page example, if we're locking at the row level and there's 1,000 rows on the page and we're modifying every one of those, that's 1,000 locks that have to be held. So the engine's trying to balance between concurrency and number of locks held as a part of its decision of whether it's going to start locking at the row level or page level. If it exceeds an internal threshold, you can get lock escalation. That always goes to the partition level if it's a partition table, or object level if it's non-partition. And it can go to the partition level if partition level lock escalation is enabled, which is the default from 2008 onwards. So that I'd actually have to check where that was introduced. I believe it was 2008, but it might have been in 2005. I don't think it was. So when we're dealing with locks in SQL Server, they're acquired at multiple levels of granularity. So they start at the schema level. When you execute a command, it acquires the appropriate schema lock to protect the schema. Then it acquires an object level, partition level, page level, all the way down to the row level. And that forms what's known as a lock hierarchy. And the purpose of the lock hierarchy is to prevent another session from getting a conflicting lock higher up in that hierarchy. So a basic example of this, if we're going to delete one record from the sales order detail table in AdventureWorks, to do that, we first have to acquire our schema stability lock. Then we're going to acquire an intent exclusive lock on the table itself. And what that intent lock says is there's a lower level lock that matters. There's multiple modes for intent lock. There's intent exclusive, there's intent shared, and there's a special one called shared with intent exclusive that I very rarely have ever seen. I think I've seen it twice in my entire career working with SQL Server. Usually you're going to see intent IX and IS, intent exclusive and intent shared. That just means that lower down in the hierarchy, there's another lock. So we're going to get an intent exclusive lock on the page that holds that row in its slot array. That means that one of the rows on that page is locked, and then we're going to exclusively lock the record that is being modified when we ghost it. So when we see IX, that tells us that there is an exclusive lock somewhere lower. When we see IS, that means that there's a shared lock somewhere lower in the hierarchy. And the purpose of those locks is to protect the resource. So when we look at lock compatibility inside of SQL Server, if you go to the bit.ly link that's on the slide, there's this really wide matrix of all the different lock types in SQL Server. There's even lock types in there I've never seen in production environments. But really, most of the time that we're dealing with deadlocks, we only have to deal with the basic lock modes. So intent shared, update, intent exclusive. I list shared with intent exclusive, but excuse me, as I said, I've only seen that a couple of times in actual work with SQL Server, and then exclusive locks. So if we look at the compatibility of these, intent locks are always compatible with each other, but they're not compatible with the more granular lock mode. So if we have an intent shared, it's compatible with shared, update, intent exclusive, shared with intent exclusive, but not an exclusive lock. Shared locks are compatible with intent shared, shared, and update, but none of the modification locks. Update locks are compatible with intent shared and shared, but not compatible with another update lock because that update lock is going to go through a process called lock conversion where it shifts from update to exclusive when the row actually gets modified. Um, Intent exclusive locks are compatible with intent shared and intent exclusive. And then exclusive locks are not compatible with any other lock mode. When a row is when a resource is locked exclusively, it's exclusive. So what's a deadlock? Um, Deadlocks are a condition when two or more processes or threads hold locks on resources and are waiting for each other to release to be able to progress. And they're not unique to SQL Server. I've written multi-threaded applications in C++ and C Sharp that have had deadlock conditions as a part of the way certain code paths got entered, right? So um, it, it's just one of those things that if we're accessing resources, and you can see deadlock conditions happen with kids on a playground if you think about it, right? One's holding uh, one toy, the other's holding the other toy. They both want it, but neither one's going to let go of it. Um, they'll stand there forever if somebody doesn't intervene and say, no, you go play with yours, you go play with yours. Or in the case of SQL Server, it's a mean teacher that like favors one of the kids and says, you get both of them. And the other one goes to timeout, more or less. So if we look at this just from a theoretical standpoint, process A locks resource 1, process B locks resource 2. If process A then wants to lock resource 2, it has to wait because it's already locked. If process B then wants to lock resource 1, it has to wait because it's already locked. And this is essentially a infinite loop of waiting that will happen unless something intervenes and handles the deadlock scenario. So within SQL Server, it's the responsibility of the lock monitor thread in the engine to handle deadlock detection. And what it does is it wakes up every 5 seconds and it searches through the lock manager and all of the locks that are held in SQL Server looking for blocking. If it identifies that a task is blocked, it does a recursive search to identify if a cyclic blocking condition exists that forms a deadlock. So if SPID52 is blocked, who's blocking it? Is that blocked by 52? If it is, now we have a deadlock. We need to deal with that. Every time a deadlock is detected, the search interval for the lock monitor thread will decrease, and it can drop to as fast as every 100 milliseconds. So if you have a system that's very deadlock prone, if you watch the lock monitor thread, you'll see that it's almost always cycling. There is a wait type for the deadlock search interval that you can track. And if you look at that and it's average across the total wait time is less than 5 seconds, it means that that thread is actually doing activity and handling deadlocks. And I'll show this during the demos. The more frequently I trigger the deadlocks, the faster they get caught and resolved. The first few that we trigger will probably take a couple of seconds to be caught. But as I go through the demos, I'll just start triggering them faster and faster, and you'll see that they resolve much quicker as that search interval decreases for the thread. Now, when it comes to deadlock victim selection, there are two really important concepts. The first is deadlock priority. And I always talk about this because this is a place that I made a huge mistake very early on in my career working with SQL Server. And as a new developer, report writer, I had the task of writing a query that quantified problems inside of our system. And I wrote this really amazingly awesome, like 15 cursor nested process that recalculated all these values, and it would take hours to run. So I would run it every day when I came in the office and go about my work. And one day I went back to my um, what was that called? Uh, Query manager window. That's not what it was called, but in the 2000 timeframe, I went back to the query and I had this big red error message. So I did a quick Google search and I found my new best friend, Deadlock Priority. And one of the suggestions was set your deadlock priority to 10 and you'll never be killed again. So I did that and things went along fine for me for a couple of weeks. Query analyzer, thanks, Peter. But then our DBA walked into my office one day and goes, "What are you doing?" And I said, "Oh, well, I'm working on this specification change for this charge and trying to make sure that we're in regulatory compliance." He goes, "No, what are you doing in the database?" And I said, "Well, nothing." And he looked and he goes, "What's Query Analyzer doing? It's open." And I said, "Oh, it's running the unbilled usage report." And he said, "Well, pull it up." And at the top of the script, it said set deadlock priority high. And he goes, "Why are you doing that?" And I said, "Oh, I had this error that popped up and that fixed it." And he said, "You're killing every other transaction that's happening in the server right now." And what I had done was I had made my priority higher than all of the new account creations that were happening in our call center. And they were getting killed as the deadlock victim by SQL Server. So usually I say don't set your deadlock priority high unless it's incredibly important that that transaction completes. What I do is I will actually analyze what's happening in a deadlock scenario and I'll set my session priority to low so that I can retry that specific operation. That way I know for a fact the deadlock condition is being handled in my code and I'm not killing something else unknown off. And that's actually not a new concept. It's the way that the distribution agent for transactional replication works by design. So if you have ever had a transactional replication subscriber set up and you have customizations or code that might be running against that for reporting purposes, if there's a deadlock, it's always the distribution agent that is killed off and then it goes into retry. Why? Because the locking conditions that led to the deadlock generally are not there the next time the transaction goes through and it just works. So if you're going to use deadlock priority, what I usually recommend is setting it to low. Does it handle the deadlock condition? No. It means that my code should become the victim. And Karthik just said we observe few improvements when set deadlock priority set low. Does that apply everywhere? No. So deadlock victim selection starts when the lock monitor thread determines that there's a deadlock condition. Then the session that becomes the victim is based on first the deadlock priority. So by default, the deadlock priority for all sessions in SQL Server is equal. If one of the deadlock priorities is lower, that immediately becomes the victim. If the deadlock priorities are equal, then it's based on the amount of transaction log that has been generated. So whoever has the least amount of transaction log generated is who gets rolled back. And that's because it's the least expensive operation to roll back. And I'll show you in the deadlock graph, this information is presented for each one of the processes. It tells you how much log has been used, and it tells you what the deadlock priority is. So my general recommendation would be don't change the deadlock priority unless you've run into a condition where there's a statement that is consistently part of a deadlock or a deadlock participant, and you want to control who is going to be chosen as the victim. For example, in a client environment, we started getting deadlocks, and they were all over the place. But there was a consistent trend that a specific stored procedure was on one side of the deadlock always. It was either the victim or it was the succeeding process, but we were constantly seeing this one procedure's statements show up in the deadlocks. So what we did is, rather than having to go make tons of code changes, we actually modified just one stored procedure. We changed the deadlock priority for it to low, and we put a begin try and a catch block with a retry around it. So it's always chosen as the deadlock victim. It's the one that gets killed, but the catch block catches the 1205 error and then retries the operation. And usually it goes through. Did it stop the deadlock? No, but it did stop the end users from getting a 1205 exception, and it stopped them from having transactions that were just blatantly killed by SQL Server. The retry can happen in both T-SQL and through your ADO.NET code. So in their case, they couldn't make rapidly schema changes that would address the deadlock, or other code changes that would address the deadlock. So we opted to handle it with a exception block that handles the 1205 and retries the operation. That's where deadlock priority really comes in handy, is being able to say, I want to be the victim and I'm going to manage deadlocks, and resubmitting the transaction, logging the error, notifying somebody, whatever, programmatically in my code. If you set everything to deadlock priority low, you effectively made no change, because when a deadlock condition occurs, they're at the same priority. Whoever has the least amount of transaction log becomes the victim. This is why select statements are very commonly the deadlock victim. If you see a select statement that is not the victim against a data modification, the next thing that I would go look at is what's the deadlock priority. Because the only way for a select statement to not be the victim is it either is executing within an existing transaction that's already modified data and there's a lot of log generation for that transaction, or somebody changed the deadlock priority. Those are the two conditions where, outside of having a different deadlock priority, it would continue to execute. So does that address your question, Karthik? I want to make sure that that explanation answers what you just asked. So the trace flags in SQL Server for collecting deadlock graphs. Today, I say all the time, if you're on SQL Server 2012 or higher, you don't need to add anything to your server. Extended events in the system health event session are already collecting deadlock graphs. If you're on SQL 2008, R2 or earlier, then trace flag 1222 still is beneficial. Even though extended events existed and the system health event session is there, they only logged to the ring buffer target prior to SQL 2012, where they added the event file. So you can always query the event file target and get your deadlock graph information. Usually it's got a few hours to a few days of data inside of those files. If not, you might add an event session that's collecting the XML deadlock report specifically and only that event, and have it write to a file. I really despise the ring buffer target inside of extended events. If you read my blog, you probably already know why. But one of the most frequent questions that I've been emailed about deadlocks is, hey, I used this script that you wrote in this article back in 2008, and I know a deadlock occurred, but I got nothing. Why? And my usual response is, wait a while. Because the ring buffer that query goes against, or sometimes I say, if you're on 2012, run this other query that'll go against the event file. But that ring buffer target holds 4 meg of binary data by default that has to be serialized to XML. And the limit for the dynamic management view that queries the XML is 4 meg. It doesn't take a computer scientist or a rocket scientist to know that 4 meg of binary data serialized to XML does not work. So there's usually a few thousand events that exist in memory that can't be output by the engine and you can't see it. So that's why I say go to the event file. Um, you can also utilize SQL Trace, server-side trace. The profiler application can collect deadlock graphs, although there's a lot of reasons why you don't want to do that. And then event notifications or WMI. I use event notifications a lot, primarily because they piggyback on Service Broker and you can automate things. So in customer environments that I do remote DBA monitoring for them, we usually deploy an event notification that sends an email to me with a deadlock graph every time a deadlock occurs. Um, that way I get the information. I can email the customer and say, hey, this happened. Here's what I think you should do. But I don't have to go digging around for it. It gives kind of an automated response and notification when that pops up. And Jason said, is a DBA coming into a new production SQL instance with 10 to 15 reported deadlocks a day? How do you start to troubleshoot the issue and find the elements of the app causing the issue? Uh, so I would go to the system health event session if you're on 2012 or higher. If you're on 2008 R2 or earlier, trace flag 1222 is the only trace flag you need. It'll write the output to the error log. And we'll look at the outputs. It's the same output. It doesn't matter which one of these that you utilize. It gives you all the same information. With the exception of 1205 and 1204. Those I list for the SQL 2000 people. That is a legacy trace flag. They were superseded by trace flag 1222. There's other things that get output as a part of 1205 and 1204, like the lock monitor search for deadlock, comments or error messages. So usually I haven't used 1205 and 1204 probably in at least 15 years. Since the 2005 timeframe, I've always gone to trace flag 1222 if I was going to turn on a trace flag. So Peter asked, do XE smart targets provide similar functionality as event notification? No. Event notifications are built on the trace infrastructure. They have not ported that to the extended event side. It's been requested forever. I don't know when or if that'll ever happen in the engine. We've seen sometimes XDL files are unreadable in SQL 2017. What could be the issue and any solution to fix that? I have no idea, honestly. It could be a permissions issue. It should be readable. If you want to email me, you could send me a screenshot of what error you're getting, and I can either try and reproduce it, or I can ask the tools team at Microsoft. Maybe I don't know. It's probably either a permissions issue or an issue with the version of Management Studio you're using potentially. With Management Studio, my recommendation to customers, and I beat this all the time, is make sure that you're updating to the latest release of Management Studio and you have update checking turned on. There's so many improvements and it's backwards compatible. So I always try and keep my machines up to date with the latest version of Management Studio. Is the script you mentioned, which emails the deadlock graph, available to the community somewhere online? Yes, I believe it is on SQL Server Central, and I think it's on my blog as well. I would have to go look and find it. If not, if you email me a reminder, if I can't find it in an article I've written, I can publish it, or Yeah, I can publish it. I mean, it's a basic script. It just reads from the queue. It's just a procedure on the event notification queue that reads and calls SP send DB mail. So it's really simple. I always create them inside of MSDB because event notifications are service broker based. So MSDB is already enabled for broker, and you don't have to do certificate signing and all these extra things to call SP send DB mail. Uh, so um, collecting deadlock graphs. As a part of the demos, there's a folder. It has a number of scripts in it. One of them is a reset script that allows an environment to be completely cleared. But if we wanted to look at our trace flags, if we do dbcc trace on 1222, you'll see here that it's not globally scoped by default. So it is session scoped, and that means that we have to use -1 to set it globally in the system. I forget what these two other trace. This is use large pages for column store indexes in SQL 2019. It's there for some other testing I was doing. Don't worry about it. And 3895 is the trace flag that enables tempdb metadata in memory OLTP. When you set that alter server configuration state, it gets added to your server configuration as a startup trace flag. So if you don't see these on your system, it's because I have a different configuration. Part of teaching column store indexes online for SQL skills is demonstrating the differences with that trace flag enabled. So what we need to do is turn 1222 off for the session and enable it globally using -1. So here we'll see it's been globally enabled, which means the lock monitor thread will report any deadlock that happens in the system. So the basis of the event notifications is actually in the demos. I don't automate it here because I have to configure database mail and I change virtual machines all the time, and I don't like putting my personal information into demos so that you would see how I configured it. But the base event notification structure is right here. We create a queue. In this case, we're going to call it deadlock graph queue. We're going to create a service in service broker to that queue for our post event notification contract type. And then we're going to create an event notification called capture deadlocks for our deadlock graph event, writing to the deadlock graph service. So if we execute this, and one note, I'm running all of these demos on SQL 2019, I believe CU1. It says RTM at the bottom there. It might be RTM. So if we query server event notifications, here's our event notification. There is a script for configuring WMI collection. I don't ever use this in demos anymore for a couple of reasons. One, randomly it's bitten me that I haven't gone back and removed the WMI event notification. And because of other things that I might be doing as demos, the CPU usage of that starts to become a problem. And I have to track it down kind of on the fly. So I don't use it. The other reason is I've never actually deployed a WMI event notification in production environments because it piggybacks on event notifications. So rather than having it piggyback event notifications, I just use event notifications. But there is a script here that has how you would do that and allow it to log to a table. You could simply change it so that it calls SP send DB mail as well, though. So we're going to use this script in just a minute for retrieving deadlock graphs. But what I'm going to do is I'm going to flip back to the slides and we're going to talk about a reverse object order deadlock. And I always chuckle when I present this slide because that's kind of redundant, right? A reverse object order deadlock is a deadlock. So it's always accessing objects in reverse order, but this is probably the easiest one to recreate in SQL Server. So we create table A and table B. For the purposes of the demo, there is a script to build a demo database. it'll load 1,000 records into table A and just one record into table B. So we'll execute a update against table A in one window. We'll execute an update to table B in another window. They're going to exclusively lock those tables, and we'll have an active transaction created by begin transaction at the top of the script. And then we're going to execute an update to table A in the second window. That's going to become a blocked condition because of the exclusive lock that's already held by process A. If process A then tries to update table B, we'll have a deadlock. And this is where the lock monitor has to do its search. It has to identify that the deadlock's there, and then it's going to choose a victim. For the purposes of the demo, it's always process B. Why? Because table B only has one record. So the amount of log generation is smaller for process B because it's only updated one row. It becomes the victim. It's rolled back, and process A can complete its update to table B. So let's go build our demo database. So we're going to create a database called Deadlock Demo, table A. We're going to load 1,000 rows into it, create a clustered index on column 1. This is for a different set of demos than what I'm going to do today. It deletes 2 of the records to allow a specific type of deadlock to trigger. We'll create table B, add 1 row. We're going to put a non-clustered index on column 2 for table A, and then we're going to create 2 stored procedures that we'll use in the next demo. So let's pop open our 2 processes. Process A, we're going to run to this run other window. So we're going to begin a transaction, update table A. We're going to come over here and run our entire transaction for this. And right now, what we have is a blocking condition. So if you were to look at SP-who is active, DM exec requests, DMOS waiting tasks, you would see that session 67 is being blocked by session 66. So to trigger the deadlock, what we'll do is update table B in this window. And if we wait for it, there's our error, our 1205. So process 67 was deadlocked on lock resources with another process. It's been chosen as a deadlock victim. Rerun the transaction. So we're going to come over here, roll back this transaction just to release the locks associated with it. And then we're going to look at retrieving our deadlock graph. So if we grab from our error log, our deadlock graph information, it starts with deadlock list and goes down to our waiter information in our resources. We can close this, we can close this, we can close this. So if we want to see our event notification, we can receive our message off of the queue, and we basically just have to process the text data out of it for our deadlock graph, which is what this X query does. So we're going to do that and select our result. It's XML, so we can click on it. And then the last way that I'll pull this up is through our system health event session. So this is going to query the system health event session and pull back our deadlock graph. And I'm pretty sure this should have had a where clause. The demos that I'll send to the VC has a where clause where it's only an XML deadlock report. So why did I bring all 3 of these up? I do it because I want to show you that the information contained in them, even though it's 3 different ways of collecting, if I'd have started Profiler and exported the graph from a trace, it's the same graph. So the trace flag, the only difference is it doesn't have the XML tags around it. If you look at these, they are exactly the same information. It's missing a couple of carriage returns because it doesn't have formatting in the error log, right? But this is the same information, including our waiter information. If we go over to extended events, it's the same information with one exception. Extended events changes just the header of the XML. So here we have deadlock victim, and here we have victim list. And extended events was modified to allow what's called, or support what's called, multi-victim deadlock analysis. And there are cases where you can have more than one victim process occur as a part of a single deadlock condition. And if you're collecting that with the trace flag or trace or event notifications, you get separate deadlock graphs for each victim. Extended events merges that into one output. And you can see all of the victim processes here. So I'm going to come back to that in just a second. Oh, no, I'm not. I'm missing a slide I thought was in here. So I'll come back to this. Let's talk about how do we go through the data in a deadlock graph. So for me, the first thing that I do is I come up to this victim process. It doesn't matter where you get it. If it's here, I always do a find, replace, and I type the word victim. And the reason I do that, and I replace it across the entire document, is now I know that this is my victim process. And when I look at my resources, I can see the victim is waiting on an update lock, and the victim owns an exclusive lock. It just makes it easier to not have to look at this process thing, right? So if you have multiple processes listed, for example, one of the queries is involved in parallelism, I might actually go down and do a replace and set each one to just process 1, process 2, process 3, whatever, to make it easier to recognize what the locks are. But most of the time, you don't have to worry about that. So I like the XML because it allows me to collapse and expand things. So I'm just going to do a replace here again. And then I'm going to close the process list. The key to understanding what's happening in a deadlock lies in the resource list. So here we can see we have table B and we have table A. And then looking at who owns which locks and in which order. Now, if you have Plan Explorer from Century 1, if you save this XML as a .xdl file and you open it in Plan Explorer, it will actually allow you to step through and replay the deadlock so you can visually see it. So if we do save as DBA-VC deadlock, and we're going to change the type to star.star.xdl, and I'm just going to throw this on the desktop. Save. Oh, no way. Century. It's the only machine I don't have it installed in. Nope, I have it. It's just not popping up. That would be really weird for me to not have this tool installed. So I'm just going to open this up. We're going to go to open, up to the desktop, open the XDL file, and here it lays it out graphically, very similar to what Management Studio does if we open it up as an XDL file in Management Studio. But you can do this play, and it actually shows the locking happening, the blocking, and then the deadlock condition. So if you've never used that, it's a great way to use that tool as well. For me, I'm still old school. I love the text. I just cannot get behind the graphical layout in Management Studio or anywhere else. So I always come back to just looking at the text, right? And here I can see my victim updated or modified table B, and it's trying to modify table A. So if I look at my process list, I have my input buffer, and I can see table B, table A, and this one modified table B. Well, why does it have a lock on table A? It doesn't give me enough information there, right? So I might have to go find where this point in code actually is, which can be problematic, to be completely honest. But if we can identify where this is by querying SQL modules or going through source control, then we can look at what else is happening ahead of this, because this is actually happening in an open transaction. And you can see that. Let's close this down. Right here with the train count. This is the deadlock priority. This is the task priority. They are completely different things. So don't confuse task priority with the deadlock priority. You need to look all the way over here at priority to know what the session deadlock priority is. And if we look at our log used, we'll see this statement has 364K of log used, where this one only has 264 bytes. So why was this a victim? Well, they had the same priority and it had the least amount of transaction log used. The question is, the Play in Sentry 1 Plan Explorer actually running against the tables involved, or is it a simulation? It's a simulation only, Radu. It's actually right off of the deadlock graph. It's not connected to SQL Server in any way whatsoever. It's just reading the information and logically replaying it as a simulation for you there. So in this case, what do we do? Well, this is one of those scenarios that the code needs to change. Why does this happen? A lot of times, in my experience, it happens because somebody wrote a process that's really old. It's running in a SQL agent job. It's been there. And then somebody wrote a new process and maybe wasn't aware of the previous process. And why did they go table B then table A? Because it looked good to them. There's not necessarily a rhyme or reason. If there is a reason why one of them goes in a certain direction, the other one should be changed to lock in the same direction, or modify records in the same direction. But a lot of times something new was introduced. It's going in a different order of tables. And that's probably where we need to make our change so that we don't affect the older process. Now, the most common type of deadlock that I've seen is a bookmark lookup deadlock or key lookup deadlock. And this is what used to be the SharePoint deadlock in SQL Server. It can happen on a heap. It can happen on a clustered index. It doesn't matter. But the key driver is that you have a non-clustered index and you have a statement that has a key lookup. So you have a data modification, insert, update, delete. To do that, it has to exclusively lock records inside of the clustered index. At the same time, you have a process that executes a select statement that is highly selective and has a very low record count associated with it typically. And that select statement drives a key lookup in the engine, utilizing the non-clustered index. And then because it's non-covering, it has to also acquire locks at the clustered index to look up the columns that aren't included in the non-clustered index. It gets blocked, and because we're modifying data in the clustered index or the heap, we also have to update the linkages in our non-clustered indexes, and this is our deadlock condition. So usually if there's a select, one of the first things I look for is there a key lookup in the execution plan? The select is always chosen as the victim unless the deadlock priority is changed, because there's no log generated associated with it. So all it has to do is release the locks and kill the session, and it goes away. It allows the other side to complete and acquire its locks. So if we look at this really fast, we have two processes, our select and our update. So if we execute our bookmark lookups, wrong thing, execute our select one time and we grab our execution plan, that was the wrong window. Let's do this again. Here we'll see our key lookup operator. And if we hover over that, it tells us down here in the output list that it's outputting column 3. So it's driving on column 2 in our index seek. And because column 3 is not available, it has to do the lookup. So if we execute these, and these have to run in a loop. So I'm going to turn our plan off because it's timing based. Um, so wait for it. It took about 3 seconds. We got our 1205. If we run it again, 2 seconds, 3. Now you'll see the faster I run it, it's going to make a liar out of me because it takes a second to hit the condition. But the more I run this, the faster it resolves. There's something else lagging in my system at the moment. I can hear the fan spinning up. I'm not sure. But this is the search interval for that deadlock or the lock monitor backing down and allowing for resolution of the deadlock more efficiently. So if we look at this, and I always bring this one up because it is probably one of the most prevalent, and it's also the one that there's a lot of options to handle. If we replace this, collapse this, and we look at our locking. So there's a pattern for this. The object names are usually the same. When we look at our index, it would be the clustered index or no index name, meaning that it's the heap. And then one of our non-clustered indexes. So if you see a shared lock against a non-clustered index requesting a shared lock against the heap or clustered index, go look at the execution plan. If there's a key lookup, usually resolving that key lookup will resolve the deadlock, right? So some of the options that we have for this would be changing the index, right? So if we change the index associated with that table, come back over here, let's pull our plan. This can never deadlock now because it's not going back to the clustered index to do the lookup operation, right? Well, I said at the beginning, what if you can't change the indexing to match all of your workload, right? What are some other options that we have? Well, would no lock work for this? Absolutely. This is one of those cases that no lock works. If we do set transaction isolation level read uncommitted, and execute this just to demonstrate we still have our lookup because I reverted the indexing. Don't do that. Execute. This will never deadlock. And the reason this will never deadlock is we're not acquiring those shared locks. So we're actually potentially getting dirty reads and we're trading it off. What if that's not a good idea though? What else could we use? Well, this is where we could drop to read committed snapshot isolation. So if you enable read committed snapshot isolation for the database, then readers won't block writers and writers won't block readers. It used to be everybody was concerned about TempDB usage for row versioning. So my counter argument to that today is, do you have a readable secondary associated with availability groups? Because every readable secondary for an availability group uses RCSI under the covers to allow read-only access to the data. How many of those have TempDB contention issues associated with row versioning? I think in my entire time working with SQL Server, I've only seen RCSI create version store issues for 2 very specific workloads, and they were very write-heavy edge case type workloads. So some possible solutions would be changing your indexing. Somebody asked about update lock hints. to resolve the deadlock. Which type of deadlock were you talking about? Were you talking about the key lookup deadlock or the update deadlock? If it's the update deadlock, no, it won't resolve it. It's already requesting an update lock. You're not changing anything. If it's the key lookup, um, would it prevent the deadlock? No, because it's still driving the non-clustered to clustered index order. And it would create the deadlock condition on the exclusive lock to update lock conflict. So I wouldn't use it there. There are scenarios where using an update lock hint really does work. Serializable isolation is a scenario where if you have a transaction open and you're doing something like a if not exists, select one from table where value equals value, and then you do an insert, that acquires a range shared lock that has to be converted to an insert lock. And in that case, using an update lock hint to get the exclusive lock earlier prevents a deadlock condition. That's the only place that I've ever suggested using an update lock hint to force a blocking lock early on. You could potentially change the isolation level. And in some scenarios, depending on what you're getting, you can modify an index to set allow page locks off. That's useful where you're getting page level locking contention because the engine is starting at a higher granularity. It does have some trade-offs, right? Every one of these has trade-offs. So the trade-off there is you can no longer reorganize the index. You have to turn page locking back on to do a reorg. Reorg requires page locks. So you'd only be able to rebuild the index. And you could potentially enter a condition where the workload becomes more prone to lock escalation to the object level. Uzil asks, is avoiding cursors and stored procedures a recommendation to prevent deadlocks? Avoiding cursors and stored procedures is a recommendation to have fast performance. Not necessarily to avoid deadlocks. It would depend on what the stored procedure and the cursor's doing. I try and avoid them as much as possible because they're row by row executions. Are there places that you have to use a cursor? Absolutely. They tend to be a crutch early on for developers who are thinking row-based or loop-based. And I understand it because I used to be a .NET developer. I used to be an object-oriented developer. And you think in terms of procedural loop-based code. Thinking like the storage engine, there's a lot of ways to eliminate needing to do loops for processing. So I see cursors used and loops used in SQL Server where a set-based solution is possible. It just requires changing the way you think about data, pivoting it instead of being flat to tabular. And without examples, it's really hard to demonstrate that. I actually have like a dirty dozen performance worst practices for SQL Server development, where I demonstrate eliminating row by row execution and how to rethink queries and patterns so that you don't have to do that. Would you turn RCSI on a primary replica in an AG for the case where there are applications reading and writing on the primary? It depends if you can execute under RCSI or not. There are some transactional semantic differences with RCSI. Kimberly has a really long white paper from the 2005 timeframe that covers all of the considerations for RCSI. And I would definitely say read that so that you understand the difference in behavior because readers aren't blocking writers. If you have a readable secondary in an AG, you're already paying the overhead for row version generation on the primary. The only thing that's different is the primary is not using version store and tempdb. So you're paying the 14 byte overhead because the version tag has to be produced on the writable primary to show up on the secondary and allow it to be readable. But I mean, I have customers that have it on. I have customers that don't use it. I have customers that use it along with readable secondaries. It just depends on your workload. When would you use deadlock priority or set deadlock priority? Uh, for Rob, so I only use deadlock priority when I'm setting it to low. And that's so that I know that my operation becomes the victim, whether it has made modifications or not. And I always wrap that in a retry block with try catch either in T-SQL or in ADO.NET so that I don't raise the exception unhandled back out to the customer or to the end user, right? And we resubmit that operation. Usually with retry, I think the longest I've ever seen retry have to go was 4 consecutive attempts because the locking conditions change so fast inside of the engine. Otherwise, I wouldn't use deadlock priority. Uh, What about updates to a table that partake in an indexed view? Sometimes the indexed view is locked on the object level. Um, that's one of those scenarios. Unfortunately, you might have to change your schema design there because of the way the index view has to materialize the results to actually make the modification. I need to see a deadlock graph, honestly, to comment further there. I understand why index views can be popular for performance tuning in some scenarios, but they aren't without drawbacks. Deadlocks are definitely one of those potential drawbacks. I see a lot of deadlocks when index views are used on subscribers for transactional replication. And the good thing there is that the distribution agent retries. The bad thing is that it goes into row mode execution during retry. So a lot of times I'll go modify the stored procedures that are updating and customize them so that they have a try catch block built into them with retry up to 10 times so that the distribution agent can apply them as a batch instead of going row by row. And it just solves a performance issue. In my production environment, sometimes I see lock on page due to update statement. Can I allow page locks off in the index? It depends on what kind of lock you're getting. Honestly, if it's an intent lock, it won't matter because you still have to get the intent level page lock. What allow page locks off does is prevents the engine from starting with a shared update or exclusive lock at the page level. And you honestly would have to look at the whole of the deadlock scenario and the query access patterns to know if that's going to be a viable solution. I can't make that suggestion without seeing more information. I sometimes find it difficult finding out the SQL job name from deadlocks. That's a good one. So I'm not prepared to answer that, but I can show you, I think. Not on this instance. So do I have? No, I don't. Start. So if you go to MSDB, the program name, how do you monitor deadlocks in SQL Azure Database Platform as a Service? There is an extended event session that you can start or gather information from that has that information. I am like 99% sure for Azure SQL Database. But I would have to double check that with Tim. I don't really do a lot with Azure SQL Database. Tim is our Azure guy. I can double check that if you send me an email, Karthik. I am like 99% sure though that there's that you can run a query. So Joe actually just answered Katie's question. So I couldn't start SQL Agent fast enough to demonstrate it. But if you look at the sysjobs table, the program name is the reverse byte order of the GUID associated with the job ID. If you send me an email, Katie, I actually have a script that I just sent to Erin that parses that so that she could find that. When you look at the deadlock graph, it will have the program name in the resource information. So here it tells me client app Microsoft SQL. Um, there it would say SQL agent and job whatever, and it doesn't match up because it's reverse byte ordered. So you have to look at it in terms of like blocks of characters and reverse them in double ED order, which is, I don't know why it does it that way, honestly, but it's one of those things that there is a way to resolve it, and I'll be happy to send you a script. My users are receiving 1205 deadlock when leaving production. Vendors suggest creating additional drives for TempDB and backup. Uh, your vendor's wrong. If you can get the deadlock graph, you can send a copy of it to me, and I'll be happy to make suggestions. It has nothing to do with TempDB or your drive layout. We need to look at the resource information that is exactly what I've demonstrated here. If you send me an email, I'll be happy to put it in writing with SQL Skills logo on it saying that's wrong. I've done that before in response to vendors are always an interesting thing, and I have to be careful because sometimes we do consulting for vendors, so I don't want to offend them, but they don't always give the right information. Deadlocks is an area that I've seen a lot of bad information from vendors. So if you want to shoot me the graph, Priscilla, Jonathan at SQLskills.com, I'll be happy to look at it, and I'll be happy to tell you that it has nothing to do with TempDB. Any other questions? So if there's no other questions, anybody that I said email me. If you email me, I will get back to you, and I will. I'm happy to look at deadlock graphs. I have said that for going on 12 years. I get deadlock graphs every week from somebody in the community. I answer every single one of them. Sometimes I have to ask for a little bit more information because you have things like triggers or schema differences that I need to see the scripts for, and it just doesn't follow a standard pattern. But I'm happy to look at them and make suggestions. So far, I've only ever had to say this is something that would need consulting work one time out of the thousands that I've seen. So most of the time, it's something that we can drive towards a solution pretty quickly and get an answer for.
Awesome.
How fast does a deadlock occur? So the actual occurrence of a deadlock, Karthik, is within microseconds, right? The locks being acquired and crossing. I mean, it depends on your specific condition. In the key lookup scenario, it's incredibly fast, which is why those always run in a loop, because the locking semantics of crossing the key lookup happens so incredibly fast that you really have to just make it run, 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 and then it hits it. The detection by the lock monitor thread can be up to 5 seconds. So uh, it, it's just a matter of that search interval. So it is possible. I've seen it. It's rare, but I have actually seen it with SP who is active. If you hit it just right, you can actually see the deadlock blocking in the output because the lock monitor thread hasn't picked up on it and it's still within its sleep interval for search. Um, can Sentry One Plan Explorer parse the block process report? I have no idea. That is a great question. I honestly don't know. I don't have one well, I guess I have one right here. So let's see if this opens and I can extract one and we'll find out. Um, Many times I get a deadlock due to triggers on the table. Any suggestion? Don't use triggers. That's one of my biggest suggestions to customers when I run into deadlocks with triggers is not to use triggers. Triggers are usually um, covering up an application level issue that needs to be addressed holistically. I understand why triggers get put in place. They become a technical debt a lot of times, and that debt has to be collected at some point, and it's not there's not really an easy way around it. Unfortunately. Could you get a copy of the slides? So this is a really good question. If you go to SQLskills.com, at the top of our page, there's a resources link. If you go to that, there is a link for demos. So let me pull this over. So if you go to resources, user group session resources will have PDFs and the demos. There's also demo scripts and sample databases. Usually anything that we present will be put up here. This one's not up there yet. But if you go to our demo scripts page, because we haven't done any conferences yet, it doesn't have 2020. But if you search on here for deadlocking, I believe it's not in 2020. It's available on our site, I know. But yes, I'll provide it to the VC and they can send it out as well. And I'm pretty sure I've presented this session before and it's been recorded by PASS at some point. I think it's been recorded at least 3 times by PASS. It was also recorded at SQL Bits and is available on YouTube as a 90-minute session. So there's a couple more demos in there. But yes, the slides will be available on our resource page. I'll make sure that Paul gets those uploaded at some point.
Awesome.
Stop barking.
Well, I don't know if there's any more questions. If you have any more questions, you guys do have his email address. It's jonathan@sqlskills.com. I really, really appreciate you coming today. We have had, all of your team basically, we have a phenomenal turnout as far as attendees and such. So you guys do amazing, amazing sessions and teach a lot. So thank you very much. If you guys have any other questions, you can definitely go to dbafund.org. And again, check out our upcoming sessions as well as past sessions. Our email addresses are there as well. It's dbafundamentals@pass.org. You can also check us out on Twitter @dbafun, on the Slack channel, or LinkedIn anytime. Also, our normal weekly emails that have this information, as well as upcoming sessions and a few little tidbits here and there too. So we will get the slide deck. They'll also be available on the website, like Jonathan said. And I hope everybody has an awesome day. Thank you.